Good morning, everybody. Glad to participate in the 26th International Conference on Fracture and Structural Integrity. The author of this presentation are Fabrizio Pittau, Fabio Doveri, Lucio Puppio, Fausto Mistretta, and Mauro Sassu, and the presentation of experimental test on vapor and gas permeability of concrete boxes. Tightness is here obtained with external coatings. External coatings are applied on reinforced concrete walls, and in this presentation are analyzed 4 separate specimens. So, after a short presentation of the method of investigation, this application is presented and the results are discussed. Reinforced concrete make possible casting and construction of monolithic structure with a very complex shape and advantages in terms of resistance and weight ratio. Two elements are very important characteristic of RC structure, the shrinkage and the cracking. These are two typical elements that affect the durability of the existing and new artwork in reinforced concrete. And in particular, these elements are responsible of the attack of concrete by external physical agents, as for example, ice, carbonation, chloride attack, corrosion, and corrosion of reinforcement, etc. This macro shows a typical measurement of the width of a crack with a micrometer. The crack is in fact the primary path of external agents that produce degradation of concrete and reinforcement and mine the durability of existing structures. Cracking is implicitly admitted all over the world in the design of reinforced concrete structures. The hypotheses of structural design are explicitly based on cracking formation. Shrinkage and cracking are nowadays considered as intrinsic property of concrete structures with which the designer have to tackle during their work. So, shrinkage, also called hygrometric porosity, derives from the curing of concrete. In time, several studies analyzed the use of anti-shrinkage additive that can reduce the phenomenon. From the other side, the cracking formation is an element that is strictly inherent with the theory of reinforced concrete. Cracking depends from the element listed here, as for example, external load, geometry, types and stiffness of aggregate, and reinforced ratio. Ongoing research aims to reduce cracking width and to limit shrinkage to reach vapor tightness or impermeability. This research suggests a classical subdivision of the function in the case of RC structures. In particular, vapor tightness is demanded to external coating, and the mechanical strength induced by, in example, internal pressure is demanded to reinforced concrete walls.
4 specimens with approximately cubic shape are tested. The mock-up for the test is arranged using a concrete cockpit, usually applied in water discharge management. The cockpit were closed by a sealer's cover and a sealer manhole. All the parts were sealed with a simple tape. The wall and the cover thickness is around 10 centimeters. That makes the test conditions very hard for the external coating. These are 2 examples of the variables used for the testing. The main characters are 3. Each one is equipped with a pressure gauge that performs 2 functions. The first is to introduce the pressure gas, and the second, obviously, is to measure the internal pressure. Here you can see the detail of the connection between the pit and the sealer with stick, and finally the fixing of the cover to make sure that the internal pressure was made with printed buds and metal rockets. The test consists to apply an internal pressure with nitrogen gas and to verify pressure and leakage. Here it is possible to see the characteristics that make the external coating test very difficult. First, the discontinuity of the material between the pit and the core. The wall thickness of about 5-10 centimeters. The ruggedness of the wood and the presence of specific deflection that very difficult to work with. The impossibility to work in the substrate due to ruggedness and to the inaccessibility of the surface, and the poor quality of the concrete, very difficult to find in a real concrete tank. Okay, let's see the test. First step was to identify the entity and main area of the cap leaks without any type of coating. Thus were mainly localized in discontinuities and in the second step, the identification of the coating, using soapy water, it was possible to properly identify any residual leaks and to measure an internal pressure with a valid pressure gauge. 4 different mock-ups were prepared for the test, each with a different type of coating. The first, the mock-up high with the polyurea, second with a mineral coating, the third with the epoxy primer and bond, and the last with epoxy cementitious. Each coating are a commercial product sold as a gas seal. Okay, then A, and here we have different materials and a complicated process. First, the smoothing of the surface with a final mortar and epoxy cementitious. And then the applying of the polymer. This material must be applied with special top spraying pumps and skilled workers. The same products was used for the entire surface and discontinuity. During the test, the behavior of the mock-up A was the best. We managed to maintain small pressure and no signs of gas leaks. Here we can see a picture of gas leak test. The only problem is a slight failing near the lid here, but this has been attributed to the imperfection of the surface on which the coating was applied. At the end of the test, when the pressure dropped, the swelling disappeared, a sign that the material remained in the last range and was able to absorb the stress. This is a very positive aspect. In fact, in the event of problem, the swelling indicates the exact point on which to intervene. Avoid to escape in case I continue. This is not B. Here we was used only one material, the mineral coating, and the processing on this mock-up was considerably easier. The coating was applied in 2 layers, both on the surface and discontinuities, and was an unskilled worker was needed to apply the material with symbols. During the test, the behavior was not good. No overpressure was maintained, and the leaks decreased, but not as much as we expected. They were found discontinuities and from cup C, in this case, we have a series of different operation materials, but all of them can be performed by unskilled work. The adhesive, epoxy adhesive, must be applied on the side of discontinuities to fix the strip. In this way, we can also operate in the structural joints. After fixing, the primer was applied with a roller, but it can also be applied with normal compressed high point or brush. During the test, we had a very slight overpressure, disturbed by the presence of punctual leaks. The losses were attributed to the surface roughness and the difficult to application of the coating on it. The pan was too deformable, and there was a swelling test was interrupted due to the fear that the pan would come off. But it was very difficult situation of the pan. In reality, we will never have a case of discontinuity in a tank use. The last lookup also in this case, the processing was executed by a skilled worker. Here, two material, one for the discontinuity and one for the walls. Fixer used to seal the discontinuity is sealed with the application gun, and the primer is applied with towel, and but it can apply with a normal plaster pump. Also, in the case the behavior of the test was not good, like the mock-up B. No overpressure is maintained, and the leaks decrease, but not as much as we expect. The polyester fixer was a good choice to seal the discontinuity. No leaks were identified.
The table summarizes the result of the experimental campaign. The best performance in terms of tightness are relative to the specimen A and to the specimen C. This last can be suggested because of the simple application of the external coating required unskilled worker. Although no one of the specimens consent to have an overpressure, but this result can be attributed to the very severe test condition. In every case, a separation of the function of mechanical strength and tightness it is suggested. If reinforced concrete can withstand to very relevant action, the tightness have to be demanded to other elements. The result of the experimental campaign shows that mockup A and C can be effectively used to ensure tightness. The possibility to inspect and check time by time the coating is a significant point of strength. In addition, the coating can be repaired in case of leaks or abrasion, scuffing, with the introduction of additional layer. Considering the limited thickness of the wall of the box and the poor quality of the concrete, the coating with mock-up A and C shows a relative good performance. We remember that no one of the specimens in this campaign consent to have an internal pressure, but this result can be attributed to very severe test conditions. The joints are a critical point to survey with care and attention. In the application of the coating plays in fact a crucial role to preparedness of the worker and the initial state of the concrete surface. In order to ensure good performance in time, some periodical check of the coating have to be done. That's all. Thanks for your attention.